Horizon Gents, welcome to UX, and this is, it's an old video, but I might as well, this is relevant right now. How aircraft carrier works. US aircraft carrier, US nuclear power ship, Nimitz class. The Lincoln, that is at the Iran, probably George Bush as well, as reports have been telling me, but nobody's talking about it. And Ford class is a bit different, more advanced, but this is about Nimitz class, the one that is literally touching Iran right now, Lincoln. Which has F-35s in it. So yeah, this video is going to be interesting. Let's watch one. If you like my reaction, if you like the type of videos I do, comment, like, subscribe, all that, and comment specific thing if you want me to react to it. And yeah, let's watch one.
This is a nuclear-powered aircraft carrier which can be divided into several parts. At the top is the deck divided into two sections. This is the landing strip placed diagonally and the steam-powered takeoff platform. On the bridge, there's the antenna and radar system along with a tower air boss to
as far as I know, in Ford class, this is more behind.
Direct aircraft traffic. Just below is the captain's navigation bridge, radar, and radio room. Inside this aircraft carrier is the gallery deck for combat and control operations, which oversee the 4 Phalanx Close Combat Support systems and the Sparrow missile anti-air defense system. The main deck, one of the largest, houses multiple aircraft and weapon systems.
Hold on, what? Wait a minute. The planes are underneath it. So why do I see planes parked on top if that's the case? What is that, overloading it more than what it can do, so they're parked it on top? Is that what it is? Because if the planes are underneath it, why is it on top every time I see it? They're parked. It's not like they're about to be operational, that's why up there. They're literally parked.
The third deck houses the engineering and electrical shops. On the fourth deck, you will find 2 nuclear reactors connected to 4 generators. Although classified, we can assume that the front nuclear reactors power the propellers closer to them, while the reactors connected to the generators power the propellers in the back. But wait, we will also look at the parts and functions of a nuclear-powered aircraft carrier explained in a super simplified animation. Let's not forget the importance of a carrier strike group, how they operate complete with its heavyweight aircraft.
Yeah, 4 Allied Bark destroyers is fine.
Fighter jets and helicopters, so stay tuned and don't miss a beat. During flight operations, this deck is considered one of the most dangerous places in the world to work. There are approximately 4 large elevators that facilitate the movement of aircraft to and from the hangar bay and flight deck. Each can accommodate 2 fully armed aircraft. In addition to the 4 main elevators, several small weapons elevators are located around this flight platform. From this top angle, we can find 4 catapults for launching aircraft off this moving airport. Together, these catapults can launch 1 aircraft every 20 seconds on average. Catapults 1 and 2 are situated on the bow. If you look closely, called the Integrated Catapult Control Station. This is a small dome located between catapults 1 and 2 on the bow and left of catapult 4 on the waist. This helps facilitate the launching of fighter jets for the aircraft carriers. As mentioned, this nuclear-powered aircraft carrier utilizes a significant amount of excess steam. So beneath the deck, they are stored in these containers ready for transporting through these pipes when needed. These systems facilitate high-energy expansion through these 320-foot-long tubes, thus powering the steam catapults. Each track features 2 cylinders that run its entire length. A piston on each cylinder is connected to a shovel extending out from the track. When an aircraft is ready for launch, it taxis into position and its nose wheel connects to the shuttle. Upon launch, high-pressure steam is directed into the cylinders, propelling the shuttle down the track at high speed and launching the aircraft into the skies. Furthermore, a water brake is employed to slow down the shuttle at the end of its run, allowing it to be retracted for its next mission. But wait, these fighter jets' exhausts are extremely powerful, so just before takeoff, the jet blast deflectors are raised upward at a 45-degree angle using hydraulic cylinders. This is done to prevent the extreme heat from damaging the high-value assets stationed nearby. Interestingly, this Queen Elizabeth class does not have catapults launching systems. This is also similar to Russian and Indian carriers.
Okay.
Instead, it relies on tried and tested ski jump process to launch its fighter jets. However, what goes up must come down. And
what? So I'm guessing British one and Russian and Indian basically, which is Russian, Vikrant, doesn't have catapults. So it literally has ski jumps that it jumps like that kind of limits what kind of planes you can use, because you really need a plane that can like jump and like create that kind of pressure, right? So yeah, something like single jet plane, that would be a problematic, right? Like F-35Cs, that would not work on those carriers. Okay, these don't have catapults apparently. That makes sense. There's a reason why India is buying a lot of the French planes, Rafales, for the aircraft carriers, so they can do that. Isn't Rafale single engine? I don't know.
And this is where this American aircraft carrier stands out. It features not one but four steel arresting cables, also known as cross-deck pendants, spanning this small moving airport. Upon touchdown, the aircraft's tail hook connects to one of these cables, bringing the aircraft to a stop in approximately 300 feet. That's a significant amount of stopping power for a fighter jet of this size. Just like an airport, they have a flight control island, also called the air boss. It is from this deck you can have an almost panoramic view. Just below it is the navigation bridge. In simple words, the captain and his crew steer the movement of the $12 billion airport. Moving further ahead is the radar room. All of the data are fed through the electronically scanned array air search three-dimensional radar system with a range of 285 miles, which translates to around 460 kilometers.
That's big.
And this tower here is a two-dimensional long-range air search radar with a range of almost 294 miles. Just below the radar room is the Combat Directions Center on an aircraft carrier. These are specialized spaces that provide information for command and controls for close and support system or the Sparrow missiles. This is the nerve center of the ship, providing processed internet information for command and control of the near battle space. But just a reminder, this is no ordinary internet connection. It has a military-grade data encryption level because you do not want hackers knowing this multi-billion-dollar position.
Could you imagine www.nimitzclass.com and it just opens whatever they're doing? They're like, of course that's not the case. Yeah, they have military, their own thing, not literal internet. That means like any hacker could basically overwhelm the entire US Navy if that's the case.
And reading your classified data. But we as civilians can also achieve this level of encryption by using private internet access. Whenever you are browsing online on an unprotected device, such as your
it was cleverly molded for the VPN area. Yeah, well, go to original video page from there, support this channel.
Below the combat room is the hangar, where it can accommodate as many as 80 aircraft. Some say this single number of fighter jets is bigger than most countries' Air Force and Navy combined together.
Yeah.
Beneath the hundreds of aircraft are the crew mess and ship galley designated areas.
It is insane that apart from US Air Force, US Navy is the second biggest Air Force there is. Like, okay, that stat alone is ridiculous.
Where military personnel eat, socialize, and sometimes live. This Nimitz class has two crew mess decks, one forward and the other located here. What's even more unbelievable is that it has a mini supermarket for the roughly 5,000 personnel to shop at their own will. But this floating...
Do they have Apple Store there? Can you buy airports? This is insane, all right?
...city needs to sleep, and the cabin crew is spread all over this floating vessel. Quarters can be found both forward and back of the ship as shown in this visuals. Adjacent to the marine quarters is the engineering hangar for repairing the maintenance-hungry jet engines. And the laundry room is located just below it, along with an equipment room nearby. As we all know, the hundreds of F-16 and Super Hornets can consume large amounts of ammunition and guided weapons. To accommodate the Universal Ordnance...
You know what? Fallout 3 has a ship that works as a town, basically. It's a whole thing, where there's a market and everything. This is like post-apocalyptic version. I hope they make one with the carrier this time in Fallout 5 or something. I mean, clearly people have knowledge, like how AITEL is talking here, like what is inside the carrier. You can just make, like, Bethesda is very good at this, creating near realistic with details, like scientific details. I mean, they try to keep the base as scientific as they can and then like twist it a bit to create a fictional world, obviously. But they could like realistically make this one, right? Like a proper Nimitz class carrier or Ford class carrier, and that works as a hub where there's everything. Like he said, there's a repair center. That could be a repair center for a proper power armor and shit like that.
Magazines that are strategically placed at the bottom of the ship to minimize the risk of explosions, and this storage compartment can extend throughout the entire ships. As you can imagine, this beast is not left unprotected. It can carry two 50 caliber machine guns at the front. Moving a bit further are two Phalanx weapon systems on both sides. Additionally, an anti-aircraft Sparrow missile has been added just close to the Phalanx. At the back, you will find Sea Sparrow missiles on both sides and a close support
yeah.
system like the Phalanx or the C-RAM. Inside this close-in support system is the Q-band search radar. Just below it is the Q-band tracking and gun-laying radar, and beneath that is the 20mm Gatling gun, which spits out 4,500 rounds per minute. All these rounds are fed from the ammunition drum. When a missile speedboat tries to get within a range of about 2 miles, the close-in support system activates and spits rounds, dismantling an enemy boat in seconds. Due to the concept of fast-flying drone warfare like this one, the Sea Sparrow can destroy it with utmost precision. It has a range of around 50 kilometers, which is 30 miles. With a $12 billion price tag, this aircraft carrier has bodyguards. A typical carrier strike group might comprise of 5 to 7 of these ships. At the center sits the aircraft carrier. These carriers can accommodate a maximum of 130 fighter jets. Flanking each side are 4 destroyers. They could be the Arleigh-Burke-class destroyers, predominantly used for anti-air warfare. Leading the battleship at the front is a Ticonderoga-class cruiser. These ships are multi-mission, covering air warfare, undersea warfare launching torpedoes, naval surface fire support, and surface warfare. At the back is the frigate class, generally serving as a light escort with a focus on anti-surface and anti-air roles, with a lesser degree of capability than larger ships. Depending on the mission, nuclear-powered Virginia-class submarines animated in our recent videos can also be added to the carrier strike group to seek out and destroy hostile surface ships and submarines.
Yeah.
The typical carrier airway...
That shit is next level. I'm not gonna lie. Like that is scary. People say submarines are scary. That is as scary as it gets. The warning shot alone that just tells you, oh, by the way, I'm here, basically would make your ears bleed, and probably do, right, whenever they do it. You know, like, I'm pretty sure it was this channel who said, like, okay, a jet engine firing inside a telephone booth. That's how loud it is. Like, holy shit. That would basically make you deaf.
Wing can include the Grumman E-2 Hawkeye. This aircraft flies ahead of the aircraft carrier, scanning the battlefield with its large radome radar. Simply put, it acts as a scout, providing early warnings of any enemy activity up to almost 100 kilometers away. They even have a mini cargo plane, the C-2 Greyhound, which they use to transport equipment and personnel. While the 6 Seahawk helicopters are designed for rescue and anti-submarine missions. These Seahawk helicopters can be launched from a specific part of an aircraft carrier. A sonar line is deployed to scan for enemy submarines underneath the ocean water. Upon detection, the helicopter can launch a torpedo at the target. Once launched, the torpedo, equipped with its own
there you go. Of course, a helicopter Seahawks are made there to detect submarines and hunt down submarines, because that's what helicopters do. Yeah.
sonar system will actively track and pursue the submarine until it successfully neutralizes the threat. Now this moving city that weighs around 100,000 tons needs to move. They do that with these 2 nuclear reactors, one positioned at the front and the other situated here. This nuclear reactor is composed of several components. Simply put, this core acts as a miniature sun within the reactor. Additionally, you will find these steam generators and powerful turbines integral to its operation. Let's compare this to a human to help you understand
It's not a sun, it's fission, not fusion. It's slightly different, but I get the point.
its size. It's important to note that this comparison depends on factors such as the reactor's design, size, power output, and efficiency. This is how it works. Step 1. These radioactive furnaces create tremendous amounts of heat that boil water. Step 2. This creates high-pressure steam that helps spins these giant turbines, indirectly powering the carrier's 8 electric generators. Yes, you heard that right, not 2, but 8 General Electric generators. This could easily power a city of 100,000 people. Step 3. Using massive reduction gearboxes, the turbines are
Basically, this wouldn't have happened if Faraday didn't do this. Most things you can see around you, Faraday has some hand in it. That's what it is. Yeah. All right. It's insane that we use nuclear technology, but we still use boiling water and spinning turbines to generate energy. We still can't figure out how to directly harness energy from a fission. Maybe until we really stabilize this fusion, we won't be able to direct application anything, right? I mean, it works. Why is the problem?
Connected to turn these 4 mammoth propeller shafts that drive the ship, giving it a speed of around 35 knots, which translates to around 64 kilometers per hour. But a quick note here, the actual speed is still highly classified. As nuclear physics is a complicated
Imagine that if it hauls ass. Oh, we told you it's classified. Here you go, 150 kilometers per hour. There you go.
subject, we'll simplify it for you through these animations. A nuclear reactor consists of three crucial components: fuel elements, which could be uranium-235 or uranium-238. These rods vary in number according to the size of the reactor. A moderator, which can be water. Control rods, whose main function is to absorb any excess or spare neutrons in the moderator.
Yeah.
Let's see how it works. Uranium oxide is compressed into fuel. Parts of uranium are packed into sealed fuel rods. The fission of uranium begins by bombarding it with neutrons. In each fission, 2 or 3 neutrons are released. This in turn causes new fissions, thus creating a chain reaction. However, in a nuclear reactor, it's important that this chain reaction is controlled after each fission. Only one released neutron should cause a new fission. This is how it is controlled. By lowering the control rods, they absorb the oversupply of neutrons. Lowering all the control rods at the same time results in stopping the
After a lot of, problems in Japan, also in Chernobyl, by now we've got proper numbers and everything right, like how to control it, what type of control rods to use. Now nuclear reactors are pretty stable and safe. Chances of accident is insanely low. So this is the time to actually use them while world is afraid of using it. We have America definitely has the technology. Look at, they have all aircraft carriers with nuclear powered. America can utilize nuclear power as a proper power with basically no emission. I mean, there is nuclear waste, but that's a different type of problem. At least it doesn't have any emissions. It's slightly costly, but in the long term it will be profitable.
Chain reaction. Now that we have mastered the basic understanding of a nuclear reactor, let's look at the step-by-step process. Step 1. The nuclear reactor heats the water to 320 degrees Celsius. Step 2. The pressure regulator is responsible for preventing water from converting into steam. Step 3. High pressure passes through a steam generator. This is where you want to convert water into high-pressure steam. Step 4. The steam helps turn these huge turbines at a very high speed. Step 5. The spinning turbines are connected to these gears. Step 6. The gears and clutch then power the electric motor. Step 7. This in turn powers the propellers of this huge aircraft carrier, propelling at speeds of around 35 knots, which translates to around 64 kilometers per hour.
The gears are not straight gears because you want it to gear into place even when it's moving. Otherwise, you'd have to be completely halted in order to do that. Like cars, reverse gears are straight, right? But you're supposed to be completely stable before applying reverse gears. I don't know, something you should know.
Step 8. The steam from the turbines is then passed through a motor condenser, which turns it into water. It is then pumped back into the steam generator, and the process is repeated, giving it almost an unlimited fuel for this aircraft carrier.
Yeah, it is unlimited fuel. Like nuclear energy, the biggest element, I mean, there is way too many plus to it, but the biggest plus is long ass energy. You basically have energy for an insanely long time. That alone is such a plus. Any other way you can think of generating energy requires constant refueling and refitting. This does not. I mean, this has its own problem, its own cost, because creating a nuclear reactor itself is costly, and sometimes maintenance can be annoying, but it is other things are completely checked, right? So at the start it will be expensive, but yeah, if the infrastructure is laid down, it will be very cheap. So nowadays people are trying to put electric everything, electric cars, electric everything, and they're trying to put hydro dams and solar panels. This is all great, trying to get energy from the sun, but you can create your own type of sun. You have the technology. So to me feels like, okay, you are level 3 technology, you're going back to level 2 to harness something. You already have how to make nuclear reactors. USA can do it, and if USA does it, world will do it, because that's how it usually goes. It trickle down to every other place. So yeah, there you go, people. Aircraft carrier, basically a city, a floating city. The people think Iran can sink. All right, this is too overpowered. The logistics of this is too overpowered. All right, I'll see you next time.